So example number 5, real-world applications. Applications in terms of electricity. So I will read the problem. If a circuit has a voltage E of 150 volts and an impedance Z of 6 minus 3J ohms, find the current I amps in the circuit in rectangular form. So let us use the formula of E is equals to I times Z. Before that, let us represent all the important terms here. So E is the representations of voltage is the representations of E. I is impedance, I is amps, and then Z is impedance. So E is equals to voltage, I is equals to amps, Z is impedance. Now, the formula is E equals IZ. And as you can see in the given problem here, E is given, which is 150. Where did I get that? From here. And then Z is 6 minus 3J. Z is 6 minus 3J. So I is unknown. To find I, so E is equals to I times Z. Divide both sides by Z. Cancel. So I is equals to, the remaining value is E over Z. Now, we already have the formula. And as you can see, the formula is in quotient form. I'll just rewrite the given. So solution, given is E is equals to 150. And then Z is equals to 6 minus 3J. So to find R1, so from E is equals to 150, let us find the R1 here. R1 is equals to the square root of x squared plus y squared. So R1 is equals to x squared here is 150 squared plus, since you don't have any value for y, so y is equals to 0. So R1 is equals to 150 squared plus 0 squared, then find the square root is equals to 150. So this is the R1. In this given, we need to find R1 and then theta 1. And then we need to find for Z the R2 and then theta 2. So E, R1 and theta 1. So you already have the value for R1. Let us find the value for theta 1. Theta 1 is equals to, every time that we are looking for tangent, for theta, so we will apply the formula of the directions as tangent, inverse of tangent, y over x. So inverse of tangent, y is, you don't have, so 0 over x is 150. So x equals to 150. Theta 1 is equals to 0. Because inverse of tangent, 0 over 150 is 0. Now, we're done with R1 and theta 1. Our goal now is to find the R2 and theta 2 in Z. So Z is equals to 6 minus 3J. R is equals to the square root of x squared plus y squared. So as you can see here, 6 is x, negative 3 is y. So 6 squared plus negative 3 squared is equals to 6 squared is 36 plus 9. So 3 the square root of 5. So this is Z2. R2. Next, theta. So theta, again, inverse of tangent, y over x. So tangent, inverse, y is negative 3 over x is 6. Is equals to find the theta, make sure that your calculator is in terms of radian. How are you going to convert this in terms of radian? So just press shift, then mode, and then look for the rad. So as you can see here, rad is 4. So then press 4. Press 4, then it will be, then equal sign, then this will become R. So find inverse of tangent negative 3 over 6 is equal to negative 0.46. So now, let us apply the formula of I. This is I equals, what's the formula that we derive? E over Z. So E is the representations for Rn theta 1, and then Z is R2 theta 2. So R1 over R2 times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. It's better if this is bracket. So R1 is 150 over R2 is 3 the square root of 5. R1 and then R2 times cosine, what is theta 1? Theta 1 is 0 minus theta 2. So this is theta 2. Theta 2 is negative 0.46. So negative is positive. 0.46 plus sine I sine 0 minus negative 46 is plus 46. 0.46. Let us divide. 150 divided by 3, the square root of 5 is 10, the square root of 5. Then this is cosine 0 plus 0.46 is 0.46 plus I sine 0 plus 0.46 is 0.46. Now, distributive property, 10 times cosine 0.46 is equal to 20.12. Then 10 the square root of 5 times sine 0.46 is plus 9.84 J, because we are looking for because this is in terms of rectangular form, or I, polar form rather. So in terms of polar form, 10 the square root of 5 cosine 0.46 plus I sine 0.46, and the final answer in rectangular form is 20.12 plus 9.84 I.